This tutorial will help you to complete the questions on homework number 6. So these first 2 lessons should feel familiar. We've done them before. Let's check to make sure you remember what you're doing. So the point J is plotted on the coordinate grid below, right down here. And they want you to plot J prime, which is the reflection, over the y-axis. And if you remember, going over the y-axis means you're moving left or right. This is the y-axis. So if you're reflecting over the y-axis, you will be equidistant, or of equal distance, from one direction to the other direction. So that's where we need to plot it. So instead of moving 2 units to the right, we'll move 2 units to the left. So once we do, we click there, and then it's going to ask us to generalize the rule, which is, what were the original coordinates? 2, -5. What are the new coordinates? -2, -5. And what changed? And what stayed the same? The y-coordinate stayed the same, but the x-coordinate changed. So when a point is reflected over the y-axis, the x-coordinate changes. See how that's reverse? If I say go over y, you change the x, because a reflection is opposite. If I say reflect over y, you change the x. Let's try another one. There's my point J, and this time it also says to reflect over the y-axis. This is the y-axis, so we're going that way. So instead of being 3 units to the right, we'll be 3 units to the left. Again, the original point was 3, 1. J prime is -3, 1. And when you reflect over the y-axis, the x-coordinate changes. Let's take a look at a question that reflects over the x-axis. So point W is plotted on the coordinate grid below, and W prime should be a reflection over the x-axis. So that means you're going up or down. So let's count these boxes here. Instead of 3 units up, we'll be 3 units down. And again, they ask you to generalize. Write the original coordinate, -4, 3. Write W prime's coordinate, -4, -3. And this time, notice that the y-coordinate changed. So when a point is reflected over the x-axis, the y-coordinate changes signs, because a reflection is always opposite. If I say reflect over x, you change y. If I say reflect over y, you change x. The next topic here is points reflected over any axis without the drawing. So remember what we just consolidated in the last lesson. Point K is located at -2, -5. Point K is reflected over the y-axis. If you go over the y-axis, you change x. All right, so if you go over the y-axis, you change x. So this is my first point, K, -2, -5. K prime is going over the y-axis, so you change x, +2, -5. And then it goes on to say, point K prime is also reflected over the x-axis to create K double prime. This one is reflected over x, so that means we change the y, or this one this time. So +2, +5. Now I don't need to write the positive signs, but I'm specifically putting them there so that you can see what's going on. So they're asking us what ordered pair describes the location of K double prime. So move K, you become K prime. Move K prime, you become K double prime. So the answer is 2, 5. 2 in the x, 5 in the y is K double prime. Let's try that one more time. Let's look at both of these transformations. So we have our first point, M. It's -4, 4. Point M is reflected over the y-axis to create point M prime. And if you reflect over y, if you reflect over y, you change the x. So M prime is a reflection over the y-axis. Y-axis changes x, so positive 4, and nothing happens to this. Then M prime is reflected over the x-axis to create M double prime. When you reflect over the x, you change the y. You change the y. So now, my point is 4, negative 4. 4, negative 4. So it's always opposite. Whatever axis I say to reflect over, you change the opposite. All right, let's identify some rigid motions. So a rigid motion is a slide, a flip, or a turn, known as reflection, translation, rotation. So it looks here like we have figure I, which is the result. So figure I is the end, and figure H is the beginning. Figure I is the end, figure H is the beginning. And it looks obvious to me that that figure has turned. So this is a turn or a rotation. So it's not a translation, it's one of these rotations. Now, 90 degrees is 1/4 turn. 180 degrees is 2/4 turns. So did you turn 1 quadrant? Right, that's 190 degrees. Or did you turn 2 quadrants? That's 180 degrees. So we only turned 1 quadrant, so that means it's one of these. One of these two 90-degree turns. So let's take a look. Did I go clockwise with the clock or counterclockwise against the clock? And it looks like, since we're going from H to I, that I went to the left or counterclockwise. So I'm going to choose this one here. That's a 90 degrees counterclockwise rotation. It's 1 quadrant, that's 90 degrees, and it's to the left. Let's try this again. V is the result of transformation of U. So V is the end, this is the beginning. So this is the start, this is the end. So how do you get from 1 to 2? How do you get from shape 1 to shape 2? So it looks like it's facing the same direction, so that's a translation. And it went to the right, and then it went down. So this point here went 1, 2, 3 units to the right, and then 1, 2, 3, 4 units down. So 3 units right, 4 units down. 3 units right, 4 units down. So let's take a look. 3 units to the right, 4 units down. There we have it. Okay, remember to read carefully. Figure Y is the result of a transformation of X. So figure Y is, the green one is the second figure, and the blue one is the first figure. And that one looks like we slid it right over. A translation. So let's look at our options here. The multiple choices are translation 3 units to the right. No, because the green is the second shape. It's definitely not a turn. So we went 3 to the left. So be a careful reader. Let's take a look at congruence and corresponding parts, right? So when you alter a figure, what parts are matching? What parts are matching? Determine if the 2 figures below are congruent. And the answer is yes. They are the same shape. They are the same size. They're just pointing in different directions. Use the drop-down menus below to justify why. So the 2 figures are congruent. Let me slide this down. The 2 figures are congruent because I rotated it. I rotated it. And that means only rigid motions happened. If something is not a rigid motion, like let's say I had a triangle. And I draw that triangle again, and I slide it over this way, right? Slide it over this way. But I make it bigger. That's not a rigid motion. If you change size, you're not a rigid motion. But this is the same size, so only rigid motions are used. So now we need to figure out which sides are the same as OP. So side OP is this longer side here, and that would be ST on this figure over there. So you simply type the letters S and T in here, and you submit your answer. Let's try that again. Whoa, right? You see this? They're similar, but they're not the same size. So these two figures are not congruent because a non-rigid motion was used. You don't know what it's called yet. It's called a dilation, but that's not a rigid motion. Now, if I had twist this and turn it, I could probably figure out which one corresponds to T. But all you really need to do is find one corner that matches, like this, right here. Point W. So W to T, WTSVU. WTSVU. Isn't that a show on TV? And so then we come over here and we're trying to look for that same connection. KGIJHK. Sometimes writing that out can help you find the match. So W matches to K, T matches to G, and that's what they were asking for. Which point corresponds to T? Well, T is second in this list, and G is second in that list, so that's how we can match that up. So T matches to G. I'll try one last time. Are these the same size? No. They're the same shape, but they're not the same size. So these are not congruent because a non-rigid motion was used. And now we need to answer the question about which point corresponds to X. Well, X is the topmost pointy part, and A is the topmost pointy part in the second one, right here. So that means X corresponds to A, and that's what you're going to type right here in the answer. You're going to type in A right here in that box. All right, last one. Identifying congruent parts. Identifying corresponding parts of congruent figures. So, oops, where's the question? Figure 1 and figure 2 below are congruent. Which point corresponds to T? So it looks like if I rotate this shape, right, if I rotate it around, I would get this small, tiny section here. Whoops, right? If I get this small, tiny section here, it's definitely going to match up with this small, tiny section there. So S will go to I, because S connects to that long down part there. All right, so let's go back and read the question. Which point corresponds to T? So S is I, so that touches S touches T, so I touches L. So S and L. T and L, sorry. S-T, I-L, so there we go. Okay, let's take a look. Figure 1 becomes figure 2. This looks like a reflection. So this one's asking about the angle. Which angle corresponds to angle D? So that's angle D on the original figure 1. And when I reflect this over, this D angle will go from the bottom to the top. That will be D. Right? When you see that it's flipping over, those would be an overlap. So the corresponding angle to D is X. Try this one more time. All right, this figure's a little bit smaller, and they want to know about a side. Side IG. So from I to G. So from I to G, and this one looks like I could have HJ on the bottom, so HJ on the bottom, HJ on the bottom, and then J connects on the long side to G, and then G to I. Okay, so now I've written all of these original letters in their locations for figure 2. So the matching side to IG would be KM, right? I is here, G is there, so KM. KM is what I want to type here. And that's it. Excellent. All right, good luck.